All right. Good morning, Math 2. This is Mr. Hewitt. Today is Tuesday, March 31, and today we are going to be reviewing the work we have done over the past few days, or should have done over the past few days. All right. Let me just clean this board. Actually, I think I'll leave this up. So, Math 2 should be working on slopes right now, or the equation of a line written in slope-intercept form. And so last class, you were supposed to graph the solution to two linear equations. In order to do that, you guys should have had completed the previous assignment, which was to graph linear equations. And this is an example of a linear equation and how you graph it. So here we have the equation y is equal to negative a quarter x minus 1. Okay. You'll notice that this is written in slope-intercept form. The slope is m and the y-intercept is b. So in our equation, obviously our slope is negative a quarter and our b is negative 1. Okay. All right. In order to graph that, you will need to start by plotting your y-intercept, which is negative 1. All right. Negative 1 on the y-axis is right here. Okay. And then to graph the line, you'll need to find another point. So you need 2 points, and you just found one. The first one you found was the y-intercept. All right. To find another point, you will need to use the slope. So because the slope is negative a quarter, right? We know that the 1 is our rise and the 4 is our run. So we're going to go up 1 and to the left 4 to get the next point. And the reason we know we're going up 1 and down 4 is because this is a negative slope. We could also go down 1 and to the right 4. Instead of going left 4, we could go right 4. So we could go down 1 and to the right 4. 1, 2, 3, 4, and that point should also be in our line. All right. But so we could have either gone here or here. But if you watch the videos on how to graph linear equations, you'll notice that you only need 2 points, and you always start with your y-intercept, and then you use your slope to find another point on the line. All right. Now, again, this negative sign in front of the 1/4 tells us that our line is a negative slope. So that means the line is going down, right? From left to right, the line is going down as opposed to going up. If this was positive, the line would be going up. So if this was a positive a quarter, you would actually go up 1 to the right 4 or down 1 to the left 4 and connect those dots and get your line. But because it's negative, we can either go up 1 to the left 4 or down 1 to the right 4. Right? See what I'm saying? So that your line has this negative slope. Okay. All right. Hope you guys come on and ask questions about your exercises. All right. Hi, Angela. How are you doing? Thanks for stopping by. Yes, I actually got this at the store. I think the first week we started this, I decided to get this. Yeah. Oh, good for you. Yesterday I ran a mile. I was a bit late. I had to get home for a online tutoring session, so I couldn't run as much as I wanted to. But I think might make this evening my long day. So I'll do maybe at least 3, 4 miles today. Yeah. Yeah. This kind of feels weird. I think I might be switching to Google Hangouts soon. Nah, that's fine. Not your fault. I should have made the switch, but I haven't. So is it similar to this? You just upload a link to Google Classroom and students can see it and click on it and join the meeting, or is there some things that more involved than that? Yeah, whiteboards are important for math. Okay, cool. Yeah, I'll check it out. Looks like I have a third participant here. Good morning. Could you just state your name or say hello so I know who you are, please? Yeah, I figured. Yeah. But I think it's time to end A block right now. So I'm gonna take a break and get ready for my B block, which starts at 10. So, well, the person left, Angela. I think that might have been one of the admins spying on me, just to make sure I'm doing something, I guess. All right. Oh, great, great, cool. Yeah. What's your mile time? Okay, there's someone else here online right now. Hello. I am just about to wrap up A block. Oh, hey, Bronson. Um, how are you doing today, Bronson? Oh, cool. Nice, nice, Mr. Souza. Hey, Bronson. Good, good. So, I'm gonna take a break, Bronson, because B block technically starts at 10. So I'm going to come back here at 10, if that's fine with you. Okay. Okay, Mr. Souza. See you later. Okay, Bronson. Hey guys, good morning. This is Mr. Hewitt. Today is March 31, and now it's time for B Block Live support. All right, let's see who's here. All right. Looks like I'm here by myself. Well, it says I have 3 people online here. Hey, say something, guys. Hey, who is that? That's right. That's Janelle, young Lillian. Hey, Janelle. Hey, Bronson. All right, you guys are here. Great. Why don't we run through an example of what we did last time, right? So last time, I think you were tasked with simplifying radical expressions, right? So let's review that, and also maybe rational exponents as well, right? So let me erase this board. All right, guys. How was your excuse me? How was your packet from yesterday? How did you guys find that? Was it manageable? Were you able to do it, or was it hard, or what? Good morning, Miss Williams. All right, so fractions confuse you. Okay, Janelle. All right, cool. All right, why don't we start there? So fractional exponents or rational exponents is just another way of saying fractional exponents. That means they have a fraction in them, right? So let's say, for example, you have okay. Yeah, so actually let's back up to Thursday's packet then. Janelle, that's fine with you. Bronson, that's fine with you too. So on Thursday, I believe you were supposed to simplify radical expressions, right? So let's say you had the number 12. All right, I think we did one like this last Wednesday, except that you were supposed to find the prime numbers of 12 or prime factors of 12. So it's a similar technique for simplifying the radical expression, all right? So we can start by, again, because 12 is an even number, we can divide 12 by 2, all right? If you divide 12 by 2, we get 6, all right? But because this is square root 12, this is square root 2, and this is square root 6, all right? So in other words, square root 2 times square root 6 gives you square root 12. Now, 2 is a prime factor, but 6 isn't, so we're going to keep breaking down 6. Again, 6 is even, so we can divide 6 by 2. All right? So if we divide 6 by 2, we get 3. 2 times 3 gives us 6. Now, because this is a square root of 6 again, it's actually square root 2 times square root 3 that gives you square root 6. And now it looks like we have all prime numbers. All right, 2 is prime and 3 is prime. All right, but here, if you notice, right, we have 2 square root 2's. All right, so what that's going to become is square root 4. Put that together, right? The 2 square root 2's are actually square root 4. All right, and we have the square root 3 here. And if you look at this carefully, you will see that you can find the square root of 4. The square root of 4 is actually 2. So this is equal to 2 square root 3. All right, 2 square root 3. All right, this should make sense. Also, you can think about this in another way too. So if you have 2 square root 2's, right, you can also write that as the square root of 2 squared, right? Remember, if you square something, what are you doing? You're multiplying it by itself 2 times. So the fact that we have this 2 times be multiplied together, I can write it like this. And you can also think about this as undoing itself, because remember we talked about squaring something being the opposite of square rooting something, right? Square root is the opposite of squaring something, right? Just like addition and subtraction are opposites, right? These two are opposites. So if you square something that's being square rooted, you're actually going to end up with just that thing or that number. So that's how we're getting this too. So a couple ways to think about it. All right. You can do another example if you want. Okay, Janelle, how was that? Bronson, are you okay there, Bronson? Not sure what you're trying to say there, but okay. All right, Janelle, how was that? How was that? Don't erase yet. Oh, sure. No problem. I need to get sound pads. What are sound pads? Okay, Janelle, you're welcome. And Janelle, these videos are going to be posted on my YouTube channel, so you can always rewatch the video. Okay, cool. All right, let's do another example. Let's do another example. All right. They help with the echo. Okay. All right. Cool. Thanks. All right. Janelle, you forgot what? Oh, you forgot what you're gonna say? I guess. All right. Let's do another example of this. So let's say we had the square root of 56. All right. The square root of 56. Oh, thank you, Bronson. No, you explained fine. I got it. I got it. Yeah, the sound patch helped me with the echoing in the room. I got it. All right, cool. All right, 56. So again, 56 is even, so we can divide that by 2. If we divide that by 2, we get 28, right? Now, again, this is another way. I'm going to do this another way, all right? I'm going to do this without writing the square root symbols for you guys, all right? So bear with me here. All right. 2 is prime, 28 is not. So I'm going to reduce this some more, or factor it some more. Again, it's even, so I'm going to divide by 2. All right. 2 times 14 gives me 28, right? Okay. All right. Again, 2 is prime, 14 is not. So I'm going to reduce this or break it down some more. So I'm going to have here 2 times 7. All right. Now I have all prime numbers. 2 is prime, 2 is prime, 2 is prime, 7 is prime. But what I'm going to do next, I'm going to look if I have doubles. I'm going to pick out those doubles and write them once. Write those numbers once. Those doubles, I'm going to pick them out and write them once. So the only doubles I have here are 2s. All right. I have 3 2s, so I can pick out a double. All right. But I'm going to write that once. Okay. And then I'm left with 2 and 7. But I'm going to write these with the square root symbols. All right. And because this is all being multiplied, I can simplify this and just write 2 and write the square root once. 2 times 7 is 14. All right. So your final answer is 2 square root 14. How was that? Any questions? Okay, Janelle. Any questions? Bronson, how was that? Let's see. Explain why the first 2 is under the right. Okay. All right. So now, as I was saying, this is just another way of doing it. All right. So if I should do it the way I did the first one, it would be square root 56, break it down, 2 times 28, square root, break this down, 2 times 14, square root, break this down, 2 times 7, square root. But here I can see that this is square root 4. So I have here square root 4 times square root 2 times square root 7. All right. And I can see that the square root of 4 is 2. All right. And the square root of 2 times 7 is square root 14. Right. So it's just another way of doing it. Yeah, just 2 different ways of doing it. Okay, cool. Okay, Bronson. I think Janelle left us. She says she had to go to do something. All right, Ms. Williams, is that okay? No problem. with this method on the right side here, you have to, while you're doing it, be on the lookout for numbers that are perfect squares. So like 4. So like here, I was able to recognize that these two will give me square root 4. All right. I could have also written another line before this, so I could write square root 2, square root 2, square root 2, square root 7. All right. And right here, you should be able to recognize that if you have a double square root, that's the same as I mentioned earlier. It's the same as squaring something, right? And if you square something, you're undoing. If you're squaring something that's being square rooted, you're doing the opposite. So you're just going to be left with that number 2. All right. So yeah, hope that helps to clarify a bit more. Why don't we look at one example of yesterday's packet, which was radical expressions, or I'm sorry, rational exponents, which is the same as saying fractional exponents. All right, let's look at that. All right. So fractional exponents or rational exponents are just expressions with exponents written as fractions. All right. So let's say we have something like 3 to the 1/2 power. All right. This can be rewritten using the square root symbol. All right. So I'm going to start by doing that. This is called your radicand. By the way, I made a new folder for you guys. It should be in Google Classroom with it's called additional support or something like that. I forgot what I called it. All right, but it's additional resources or additional resources. Additional resources pertain to this topic. All right. All right. So that's called the radicand. So that's going to go right here. All right. This symbol right here is called your radical. The radical symbol. All right. This 2 is going to go right here. All right. And that 2 is called your index. All right. And this one is going to go right here. All right. I could have also written this like this. So 3 and to the power of 1, which you don't need to write, really. All right. And this index is 2. All right. When the index is 2, guys, you won't really see it because it's assumed that you know that when something is being square rooted, the index is 2. And so you won't see that 2, except it's something else, like the 3rd root or 4th root. All right. So time is up for B block, but I'm going to do one more example. So let's say you had 4 to the 2/3 power. 4 to the 2/3 power. I'm going to rewrite that. right. 4 is going to go here. The index is going to be 2. I'm sorry. The index is going to be 3. And your exponent is going to be 2. All right. I think I got that right. All right. So I can rewrite this in another way too. This can be rewritten as third root of 4 squared. All right. They're pretty much the same thing. All right. And we can talk about why this is. I think there's a lesson that's about exponents, which will explain that some more for you guys. But anyway, that's all I have time for right now, guys. I have to get ready for my C block. So again, you can rewatch these videos. All right. So you guys have a good rest of your day. Whoever is there right now. It's like one more person. All right. You have a good day and God bless.